Okay, so we're doing Leetcode weekly contest 282 and we are late. Okay, so we're given an array of string words and a prefix. Return the number of words that contain that prefix. Okay, got it. So let's call it words. Let's call it S and this one T. Alright, so answer equals 0. So for every string in S, um, let's say auto p equals t dot find, sorry, s dot find t. If t equals 0, then okay, if x dot size, not really sure if this is required, but yeah, I'll do an answer plus plus. Example test s dot find. Okay, not s, it should be x dot find, string dot find. C is 2 and 0. It seems good enough. Okay, they both are non-zero. Okay, this works. Next problem. So we're given two strings s and t. In one step, you can append any character to either s or t. Append. Okay. Return the minimum number of steps to make s and t anagrams of each other. Right. Append. We can append, right? In two steps, we can append the letters um, in as onto s. Correct. Okay, and in five steps we can append. Okay, like append at the back because they are we can append anywhere, right? Because they are anagrams. So order does not matter at all. Right. So what I'll do is in count of are they all small case? Yeah, they're all small case. Okay, let's make a vector. That would be better, I think. Vector int count of 26,0. Right, so everything is set to 0 initially. Now what do I want to do? I'll iterate over the first string, correct? And then what should I do? I should do count of x minus a plus plus. This will set the count. Then what should I do? Now, got it. Now for auto x colon t, count of x minus a minus minus should be good. Answer equals 0 for int I0 y less than 26. I plus plus answer plus equals apps of I think count of I. Return answer. I think this should be good because 7 and 0, right? 7 and 0. It looks good. Can it answer be long? No. The constraints are pretty small. Okay, this also works. Going to your third one, you're given array time and which terms are time taken by ith bus to complete one trip. Each bus can make multiple trips successively. That is the trip. Okay, immediately after the first one. Also, each bus operates independently. Okay, right. You're also given an integer total trips, which denotes the number of trips all bus should make in total. Return the minimum time required for all buses to complete at least one trip. Right. T question. Okay. Okay, we want to find out minimum time. Right. Okay, I think we can binary search in this one. Okay, why is the answer long? Because one can take 10 past 7. Uh, if let's say one trip takes 10 past 7 and there are 10 past 7 different trips, so 10 past 14, correct. At 0, let's take no, no, L0 R, let's take 1E15, I think. Number 15. Okay, and I'll have an answer variable. Right, now I need to check how many trips are possible in mid. Okay, so let's set a variable um, for auto x colon time count plus equals mid divided by x. Okay, yes, count plus if count is greater than equals to total trips, I say answer equals mid and L equals to mid minus 1. Else R equals to mid plus 1. Return answer. And this should be as long now. Okay, now I just need to think about, can I ever overflow this? Oh, 10 power 15, right? 10 power 15 and 10 power 5. Yeah, that will overflow. What if I do 10 power 4 or 14, sorry. Hmm. Okay, even now there's an issue, right? If he gives me an array, okay, let me think about what should be the upper bound for this. So one chip can take 10 power 17, correct? And no, one, yeah. So one chip can take 10 power 7. And what do you want? Let's say you want 10 past 7 trips. In that case, it should be 10 past 14. My worry is there are 10 past 5 different these. If count is greater than 2015, break. Instead of 2015, yeah, I think 2015 is good. Let's give it 2015. Count is greater than 2015, then simply break. Hmm. This example test case, let's see. Time limit exceed. Okay, R equals to mid minus 1. And here this should be L equals to mid plus 1. Let's say 3 and 2. 3 and 2. It works, but will it work? Okay, I don't want count to be overflowing, so this is the condition. Hmm. It looks good. Okay, let's just submit. Okay, this works. Last problem. So, given a zero index 2D array tires, okay, this indicates the ith tire can finish the xth successive lap in, okay, fi times ri to the power x minus 1. For example, fi3 and ri2, the tire would finish first lap in 3, second lap in 3 times 2, third lap in 3 times 2 square. Okay, you're also given an integer change time and an integer number of laps. The race consists of number of laps, and you must start the race any tire. You have an unlimited supply of each tire, and after every lap, you may change to any given tire, including the current tire type if you change. So if you wait, change 10 seconds. Correct. Okay. Return the minimum time to finish the race. The first one. Okay, let's see. Lap 1 start with tire 0 and finish the lap in 2 seconds. Correct. Continue tire 0 and finish the lap in this much second. Change tire to any tire 0 for 5 seconds and then finish the lap in another 2 seconds. Constraints. What are the constraints? Okay, right. How would I do this? So I have two options every time. Either to change the tire and pick a new one with its reset value, or or continue with the current one. But in case of current one, this is going to increase. So this whole value will be significantly larger. All right, let me see. So RI is at least 2. Okay, and up to 10 power 5. Correct. 10 power 5. Mhm. And what is the change time? This is also 10 power 5. Okay. Mhm. How should I approach this problem? Let me try to think. Okay, so what if I maintain a queue? Priority queue, something like that. What is the hmm, least possible value? Okay, how? Now the first question is, when do I want to change the tire? When do I want to change the tire? So in that case, change time plus new tire, new tire initial time. Should that be less than next time? I mean, okay, next lap time. So this time is basically from the current tire. Okay, this is always true. Maybe new tire um, has a bad R. I mean, R is very high. So again, like I'll have to switch very quickly. Maybe that's not a good approach. Okay, let's think about this. Number of laps are 1,000, and what is a small? Yeah, everything other than that is pretty big. Number of laps is 1,000. Okay, so I was expecting some kind of DP here. Okay. Hmm. Okay, one thing for sure, what should be the worst uh, case time I can do this? Because this it says it's an integer always, right? Okay, let me think. So this is 1,000 lap. Every lap we take maximum. of 10 power 5 plus 10 power 5, right? Change time is also 10 power 5 and Fi is also. Every that क्या होता है? Every lap should take maximum in 10 power 5 and there are 1000. So 2 to 10 power 8. Yeah, that's very clever. That's why this is an integer. Okay, now do I want to do a binary search? That's the question. Hmm. Okay, if I think about this in terms of DP, okay. So using IS tire in GitLab, okay, I cannot use IE here because that's 10 per 5 already. Then another 1000 that would be pretty bad. Hmm. Okay, so first of all, let's see, I mean, why grid is not working. So every time what I'm doing is every time I choose a one this with this condition, change time plus new tire initial time is very small, correct? But what if change time is very high? I mean, again, in next turn, this might become very high because of, let's say, a higher R, then that would be an issue because I want to choose something. In that case, where change time is high, I would choose something which has a low R. But even if R is as low as 2, okay, as low as 2, so in the first iteration this should be 2, next one this should be 4, and then it should be 8 and so on. Okay, so first of all, never a good idea. Okay, just hang on a minute. Do I? No. No, that's not true. 2 per 8, 16. Okay, how fast does this increase? 10 past 5, right? 10 past 5, I think it's somewhere around 2 power 18 or less than that, I think. 2 power 18. So basically, in the worst case, ever, um, one tire will be used to about 20, let's say to about 20, because there's also, um, yeah, let's say to about 20. In worst case, a single tire will be used 20 times without changing. Correct? 20 times. Then I'll definitely have to change the tire. Okay, is this some kind of, I mean, so it can have, that's the first tire, which is, let's say A of 1, completing zeroth lap takes time, how much? 2. Okay, for let's say for first one, um, for the first tire, these are the times, let's say, okay, 2, 8, 20, and I'll make this list till what, 10 past 6, let's say, worst case. And this is pretty easy to make, right? So for every tire, I'll have this list. Now, okay, let's say this one is something like 5, 20, 60, and 120, something like this. Although this is not correct, but yeah. Now, what I want to do is, okay, let's just say that the very first time we also choose something, this will incur us some time. Okay, so we'll include a constant factor of t here. Okay, what else? Now I want to do what? Now I want to choose a prefix of these in such a way that the number of elements are as small as possible. How would I do that? How would I do that? Oh, I think this seems like a DP. Yeah, this is a DP of II, right? So basically, min, okay, it's only I think DP of I. Yep, mean time taken to complete I labs. And how would I calculate that? See the previous 20. Let's see the previous 20. Yeah, that makes sense. Correct. Look at previous 20 and choose any one of that, right? Oh, this seems good. Okay, so number of labs. Let's call it T. Let's call this one A. Okay, so let's just comment this entire part. Okay, no, what am I doing? Right. So I'll have a DP of size, how much? 1000, right? 1005. Now, what do you want to do? Let's just reset this DP. DP minus 1 size of DP. Okay, I also want another array which is vector 8. Let's call it V. Now, this array is nothing but this array, so let's replace here V. Right. Now, very first thing should be I should initialize this vector V. Right. Let's just take n also. N equals a dot size. I equals 0. I let and I plus plus. Now, initial time will be t. Right. What do you want to do now? Okay, I'll take a long. Should I? Let's see using int only first of all, and we'll switch if we feel like. Now, I have this t initially. I want to find this 2 and then all the next steps, which is fi times ra. Okay, fi times ra, which is a of I of 0 times a of I of 1 Okay. Um, this should be it, right? While one, and this should I should take into some variable. Call it exp. Is this times? Okay, initially exp should be zero, right? Exp should be one times exp. Exp is equals to exp times a of I 1. If exp is like so this is let's say 10 power 5. This is already 10 power 5. Okay, I'll take this as long only, just to be sure. If exp is greater than what? Int max? Should I even take that? That's not at all required. 2 into 10 power 5. Okay, let's just say 10 power 6. 1 6, which is 1 6. I'll simply break long. I'll put the same condition for x also. If x is greater than 1 6, simply break. Okay, so this is nothing but cur plus equals. No, wait a minute. Let it be x only. Hmm. Keep this in the end. Essentially, I want only this to be constrained. Okay. Okay, cur plus equals x. Right, cur plus equals to x, and what I'll do is v of I dot put underscore back. Cur. Right, this should be good. Now I'll have all the terms here. I'll have my dp function now, which is for the n minus first tire, and okay, sorry, not this number of laps. Complete this many laps. Return solve of this. Okay, and I should keep this n as global variable. And n now, if laps equal 0, then I can return 0. If what? If laps is less than 0, then I return a really large number. Just let me return 1e9. Yes. So if dp of laps is not equals to -1, return dp of laps, correct? Then what do I do? Then I'll loop over all of these. But do I want to loop over all of these? I think I'll have to do that. In worst case, we can have 10 power 5. And how many times will this go on? 10 power 5 into 10 power this, so 10 power 8 times. Uh, Not so good. Okay, dp of labs is equals to min of dp of labs, comma, solve of solve of. Okay, let's not do this like this. Okay, now I'm a little worried. This might give me a TLE. So I'm using, let's say, the first J, right? This should be labs minus J plus 1. I think because if it, even if it is goes negative, I'll select it as 0. Minus J minus 1, I think, plus V of I, J. And I'll just select dp of labs. Yeah, now I'm worried this might give me TLE. Because this is what, 10 power 5 into 10 power no, into what, into 20, correct? So 10 power 6 already, and we'll have how much? 10 power 5 different states. Not 10 power 5, sorry, 10 power 3. This is the value of n. Now, actually, this is not that big of a problem, right? Because 10 power 5 into 10 power 3 is already 10 power 8, which is a pretty big issue. Right, shouldn't I be doing something like this? That for first for 5 laps, which is the minimum, right? I should be doing that kind of thing. This is not good. I'll just comment this part out. Now I know that maximum I'll do is 20 laps. The maximum is this at one time. Okay, okay, now I should find what is the best for this many number of laps. Okay, so we'll make another array which is vector int best. Let's call it 25. Hmm. This is also long, correct. Hmm. I'll just loop over all of these, right? For int I0 I less than n I plus plus for j equals 0 j less than int of uh, best should set really high, which is int max. J equals 0 j less than v of I dot size. Okay, I'll loop over all the elements and best of j plus 1. Min of best of j plus 1, comma this value v of ij. Makes total sense. Then what do you want to do? If best of I equals int max, then I continue, or I should break. Doesn't matter. Then what should I do? I should do dp of labs is equals to min of dp of labs, comma, solve of labs minus I plus best of I. This should be my answer. Okay, I took too much time on this problem. Best of I equals int max. It gives me an issue. Okay, this is not a vector of integer. It should be simply an array. Gives me a runtime error. Index 25 out of bounds. How is it even possible? R less than n I plus plus cout v of I dot 5 enter 29. How the hell 29 possible? 1, 2, 3, 4. 1, 2, 3, 4. It says for 2, 2. Let's see. Hmm. 14 is how much? 6. Um, 2 into 3. Yep. 23. 2 into 6. 2 into 9, sorry. Which is 18. Yeah, this seems good. I'm just wondering. Okay, this one. It's not 29. Then why did I get 29 here? Let's run it again. Okay, this is wrong. I have to reset also. Um, for int I equals 0, I less than equal to n I plus plus v of I dot clear. Okay. Anything else? dp is already cleared. V clear passed. I'm always resetting to int max. 26 and 31. 26 and 31. Seems good. Minus t. 21 and 25. And this is good, but the only issue is it good? Hmm. Okay, let me quickly see if I can spot any mistake. I took a long. Okay, let's do one thing. Let's use long for everything just to be safe. We don't want an overflow, right? If this is greater than instead of 26, is 26 good? Um, I don't think it is good. Okay, this is good because I don't want the current value to have more than 2 to 10 power 5. Oh, is it 10 power 5? So let's say if fi is 10 power 5, Right, and then change times to 10. Yeah, 10 per 5. I think this should be good. Alright, this should also not exceed 1 e6. Current is that, so it shouldn't be an issue. Let me run it again. Hmm. Right now it looks good. Should I take a chance and submit? I think I'll take it. Oh no, give me a runtime error. What is the test case? Basically tell me where it is giving a runtime error. Okay, it's not telling me, so I need to find it out. Let me see if this is printing or not. Okay, it's not printing. Run code. Why? Let me do a return 0 here only. Oh, this is why it is giving me an issue. What if I do this at the very beginning? Let's do okay, this is good. So where is the issue? Here, but how is it possible? No, it shows not here. And equals e dot size. Scout and space here. Is A? No, it should be good. Run code. Now this is good. Let's see if this is working. What am I using here? Less than equal to n. What is this is bad. I what am I even doing? This shouldn't be n. This should be less than n. Oh no. That was very stupid of me, but still, this is giving me. See if I get clear. Okay, so far it's good. See out here. We also return. Okay, this is not printing. See out I. Okay, so some issue with some issue here. Not really sure what is the issue. Okay, this is print. This will tell me how many times it is running. Let's just see at the end if something is running really large number of times. No, it's not. It is a global buffer overflow on address. This. Okay, did I overflow the memory or something? And do I even need to store this V? I don't think so. I need to do this. I can simply store in best. Okay, I'll comment this part out. Put it here and hmm, comment this and say best of j equals min of best of j comma current. This is good. And I'll also have a j which is starting from 1 every time. And this will increment j plus plus. VFI dot clear. Where is it? Where is it? Here. Hmm. Okay, this we have to remove now because it's not required. Hmm. Do we get any answer? The answer is 0. Okay, it's because of this. Where am I printing now? I should remove the print statement. Cout high and cout high. Run code. Oh no, come on, printing angel somewhere. Okay, I at least have some answer, which is 1094.16. Does it show me expected? No, it doesn't. Use example 2125. That is good. Anything else I need to worry about? This is this is done. Run again and simply submit. Yeah, I'll make a submission. Oh, this works. Nice. So let's see if we can get into 200 because it doesn't seem like. Okay, there are only 40 minutes left, so I think I took significant time on this one. Yeah, around 40 minutes. Let's see. But how many people have done this actually? Okay, my timer is 54. 54. So currently top 120, 130. But yeah, there will be more people. But yeah, this was a good problem. Like this problem. Okay, it's total 147 submissions. So yeah, I think we should be around 200, or maybe just out of 200. Okay, cool. So I'll go over the submissions once. Go to the first problem. Right. So the first problem was, so we are given a set of strings and we want to find out how many strings they start with this prefix. So yeah, so here nothing fancy, try, etc. Just simply because the constraints were very low, I was just doing a string dot find operation. So this is an inbuilt method. So yeah, this takes worst case of n, I think. So s dot find t, if you're able to find it, it should be at the 0th index, right? Then only this is the prefix. So it will find here for the very first time. And one property is that this function will give you the first occurrence. Okay, this will give you the index of first occurrence. So that is, if we talk about this string, then we will get 80, that is the 0th index. And if we do get that, we'll do an answer plus plus. Yeah, I was not sure if a string could be empty. Yeah, turns out they can't. So this thing is redundant, I think. We could remove this. Okay, yeah. So this was easy. Just loop over all the strings and check for each string if this satisfies the condition. If it is satisfying, we'll increment the answer. Okay, going to the second problem. Right, this one. So basically, we had two strings. Now we can do one operation, which is you can append any character here, A, B, C, D, anything. You can append any in one operation, right? And same you can do here as well. You can append any character in one operation. So you have to find what is the minimum number of operations you have to do on these two strings such that they both are anagrams of each other. So if you don't know about anagrams, so anagram is basically just a fancy word of saying, they both have same characters, right? So yeah, so in this example, what we can do is, so we can append AS to Leet code, and we can append this string LEED to the second one. So both of these strings will have exactly the same characters, right? And this took us how many steps? Two steps here and five steps here, a total of seven steps. So the way I did this one is I made a frequency array, right? And then I looped over the first string and incremented the count of all the characters that are present in that string. So this is nothing but I'm finding the frequency of every character in the first string, right? Then for the next string, what I'm doing is I'm decrementing that counter. So if you think about this, I'll give you an example. Let's say the first string has um, A, C, and the second string has A, B, correct? So, okay, so after we process the first string, which is this loop, our count array would be count of A would be what? Count of A is actually 3. Count of B is actually what? 1. Count of C equal again 1. So when we do this for loop, we actually decrementing the count for the second one, for the second string, right? So now your count will update to something. Okay, this is 1. Let me just copy this on. Yeah. Okay, so because we have one A, so this will decrement by 1, so it will become 2. We have three B's, so this will 1 minus 3 is nothing but minus 2. And this is 0, right? This is our new count array, new frequency array. So if you think about this, if any value is positive, so this is positive, this signifies that the first string had that character more than the second string by this many number of times, right? So first string has A two times, so two is more than the first A, with more than the is in second one. And if a value is negative, it means that the second string had more occurrences of this character by, by 2. So we had only one here and we had three B's here. Right. So yeah, the way we can find the answer is we take sum of absolute of all these numbers. 2. So we do abs of 2 plus abs of minus 2 plus abs of 0. This is nothing but 4, right? So this would be our answer, right? So this positive and negative just signifies which string has more count of that character. This is also fairly simple. Next one was minimum time to complete trips. Right. So basically, we given, the time duration for time taken by ith bus to complete one trip. So the first bus takes 1 minute or 1 hour, whatever. Second bus takes 2, and third bus takes 3 to complete one round, right? And we want total 5 rounds, and all these are working in parallel, so they won't affect each other. Right. So how much time it will take us maximum to do this many number of trips, right? We want to find the minimum time. So, okay, whenever we say find us the minimum, right? And okay, so if you think about this, if I give let's say infinite amount of time to you, it's always possible to do this many number of trips, right? But we are interested in finding that minimum time, which enables us to get 5 trips. In this case, answer is 3 because in 3 time, this bus will do 3 trips. This one will do one complete trip and one partial. Will not count the partial, so that will be ignored. And this bus will do one trip. So total 3 plus 1, which is 5. Yes, this is the least time. We cannot do less than 3. We can't do it in 2, right? So whenever we see this kind of property that, if you think about this problem is saying you have to minimize the maximum, right? So basically, answer is always possible, but you want to find the minimum value for which the answer is satisfied. So whenever you see this, or the vice versa of this, which is maximize the minimum, you always can use binary search, right? So what I did was I took a range which I think would the minimum and maximum answer be, right? And then I'm just searching over this range using binary search. What I do every time is I find the mid, which is L plus R by 2, and then for that mid, what is the number of trips I can do for this much time, right? So how do you find that? Using made by the time taken by ith bus. Okay. So we add this to our count variable. This is the total time. And just if at any point exceeds 115, we simply break. Now this is just a safe, I think, safe check to make sure we do not overflow because there's a possibility to overflow this. And how can we overflow that? Okay, so this is 0, this is 10 power 15. So 0 plus 10 power 15 by 2 is nothing but 5 into 10 power 14. Now, just imagine I have an x equal to 1 and the array size is 10 power 5. Okay, so essentially what I'll be getting is 4 into 10 power 15 times 10 power 5, 10 power 14, sorry. So this is nothing but 10 power 19 to 10 power 19, which will overflow, I think. I think the maximum limit we get is 9 to 10 power 18 for a long number. So this was the reason why I put this condition here. I'm not really sure. When I try now, I think this will overflow. Let me just, okay, this is working. Let me do this. Yeah, this will overflow. I knew this. Oh, where is it overflowing? Basically, yeah, this is overflowing here, right? So that actually was required. You cannot do this without this one. Okay, so this was the logic basically that for every mid, you check how many trips you are able to do. If you are able to do at least the required number of trips, you set your answer here, and you also reduce your space, which is basically, so let's say if you had, let's say this range, this is your L and this is the R. So if your mid is this, and you're able to find answer here, I mean, this is satisfying the condition. So you move your R to mid minus 1 somewhere here. Okay, somewhere here. Right. Otherwise, you move your L to mid plus 1. So yeah, this is fairly trivial. So moving to the next problem. Yeah, this last problem was interesting. So basically, you're given an expression to find how much time it will take you for the IS tire in the jth lap, in the xth lap, sorry. Right. So one thing to note that is answer. Um, so one lap you'll never do in time worse than 2 to the 10 power 5. You would never do a lap in worse than this because Fi is 10 power 5, change time also 10 power 5, and let's say I change tire every time I do a lap, okay? So 10 power 5 into this would be 0, so anything to the power 0 is actually 1. So this took you 10 power 5 seconds plus the change time. Change time can also be 10 power 5. So 10 power 5 plus 10 power 5 is equal to 10 power 5. So you would never do worse than this. This is the worst case you would do for any trip. All right. Then what I did was, okay, so for every tire, I was checking that what it will take this tire to do one round, then two round, then three rounds, right? And I'm doing this for at most 20 rounds because if you do more than 20 rounds, right? So this is power 20. So this is basically if you're doing 20 rounds continuously from one tire, okay? Anything power 20 and that anything is greater than or equal to 2 would be greater than or equals to 10 power 6 for sure. Because if you do 10 power 2 power 20, this is actually more than 10 power 6, right? So yeah, so I have this infinite while loop. So this will run for 20 times for every tire, at most 20 times. Okay. And every time I calculate the value of that expression, add it to my initial time, to my curve variable. So one thing to note that is um, I'm using curve initialized to t, which is the change time, right? So I changed this problem in one thing that the very first time we start with a tire are also including the change time there. So this will actually, make me generalize things. So um, I'll simply have to do my minus t at the end to eliminate that time. Right. So this was the reason why I initialized it with t because I wanted to include this change time for the first time as well, the first time we choose a tire. Right. So now I have best array with this array tells me, so best of I tells me that what is the minimum time I can do I rounds consecutively without changing a tire, right? So if I say about this, so best of I tells me main time it took to complete I rounds consecutively. I rounds, I just say without changing tire, using any tire. Okay, you can choose any tire. Right, so every time I was updating this best as I was calculating that value of current for all steps. Okay, so yeah, now I have my best computed. So this problem basically reduces to a DP that so DP of I is nothing but mean time taken to complete I laps. And we know that we'll not do more than 20 laps consecutively, right? So at every state of this DP, I iterate over the last 20 states. So let's say if I think about this, let's say I'm currently finding out DP of 500. Okay, so what I'll do is I'll say that I'll do I'll do one iteration from one lap from one tire. So I'll say DP of 499 plus plus best of one. What? Okay, plus best of one. So essentially, I'm saying it. I'm doing one lap from the best tire which can do me one lap, and then rest for the rest I'll change the tire. Okay, so this is one possibility. Other one is you do two laps from the best tire which can give you two laps, and then ask the rest of the then you ask for the rest of the GP, which is 498. Okay, I'm doing this for 20. iterations because the worst case, like I told you, it's actually bad to do more than 20 laps consecutively, right? From one time. So this would be something like 480 or 481, something like that. Okay, best of, not best. This should be DP. DP of 481 plus best of 20, something like that. Okay, so I take min of all these. This is my final answer for this is com actually. This is my final answer for DP of 500. And this is fairly simple. Yeah, if it is already computed, I return that answer. And if there are no laps to be done left, I say zero. I take zero time. And then, yeah, the standard 20 iteration step. This condition is basically to avoid those cases where it's not possible for any tire to do that many number of iterations, right? Um, because that will be too bad, right? So I was setting initializing every pass to 10 power, sorry, int max. And then yeah, finally return this, and yeah, so this what's the time complexity of this? This is n log n. For every this, I'm doing log number of the second loop. Then okay, actually not n log n. This is n log AFI, whatever you call it. N log maximum value. What is maximum value? Hmm. Okay, I can just say if you think about this. Um, yeah, again, it's log only then. It should be n log a of. Hmm, hmm. How do I say it? I mean, it's power of this number. So I think we should just simply say it maximum 20 times. So this is actually not 2 of n times you can say some logarithmic factor. And this logarithmic factor is always less than equal to 20. And what about dp? This is O of number of laps only, I think. Yeah. This 20 will not account for, yeah, it's similar. O of laps time 20. So that's it, I think. Yeah. So let's see. I mean, where are we standing now? Is it 200? Oh, really? Did I really get 124? Okay, no. Oh, I did got 124. Okay, yeah, that's cool. All right, yeah. Thanks for watching. See you in the next contest.